Hello, this will be a demonstration of Proposition 11 from Book 3 of Euclid's Elements, which states that if two circles touch one another internally and their centers be taken, the straight line joining their centers, if produced, will fall on the point of tangency. What we are given is the circle ABC and the circle ADE touching one another internally at point A. What it means for two circles to touch one another internally is exactly this, that one is nested inside the other and they touch each other. We know what it means for circles to touch one another. We'll call this not A, that'll be B, that'll be C. And if we take the center of these two circles, ABC and ADE, which we will call point F and point G respectively, then the straight line joining them, FG, if produced, will fall on the point A, which is the point of tangency. And if this is not the case, and we take their centers, like so, and the straight line joining F and G does not fall on A, then it falls on some other point H, like so. Next, we shall join the straight lines AF and AG, just by the common postulate one that we use in every proposition. Now, we know that AG plus GF are greater than FA. We know this by proposition 120, that in any triangle, two sides added together will be greater than the remaining side. So if we add AG and GF, they'll be greater than the remaining side, AF. Now, by definition 115, AF and FH being radii of the same circle, namely ABC, will be equal. So AF and FH will be equal. So by a property of magnitudes, we can then say that AG plus GF is also greater than FH. And if we subtract GF from both sides, well, FH minus GF, so we have FH here, and if we subtract this length here, GF, we're left with the remaining length, GH. And so we can say that AG must be greater than GH, that is common notion 3. We also know by the same definition, definition 115, AG and GD being two radii of the same circle, ADE, must also be equal. So we can say that AG is equal to GD, and by a property of magnitudes, we can then say that GD is also greater than GH. Now, GD is certainly greater than GH, we just proved that fact, but by common notion 5, the whole being greater than the part, we know that GH must be greater than GD, and GD must be less than GH, because GD is a part of GH. And so GD must be simultaneously greater than and less than GH, which is absurd. And so we can say that the straight line FG will not fall on any other point other than A. And so we know that the straight line FG, which joins the center of the two internally tangent circles, will fall on the point of tangency, that is point A. This being what we set out to prove, we are done with the proposition, therefore, etc., QED. Nothing to say about this proposition, so I will move on to proposition 312.